Hello and welcome to Vision Academy. In this video, we are going to learn binary addition. Let us take two decimal number that are to be added. That is 50 plus 25. So this results in 75. So but we have to convert both of these two numbers, that is 50 and 25, into binary notations. Now let us write 50, divide this given decimal number by 2 until quotient becomes 0. We have to note down the remainders. 2 2s are 4, carry 1, 2 5s are 10, and remainder is 0. Next, 2 1s are 2, 2 2s are 4, remainder is 1. 2 6s are 12, remainder is 0. 2 3s are 6, remainder is 0. 2 1s are 2, 1 is the remainder, 2 zeros are, and this quotient 1 will become remainder. So as per basic mathematical rule that says, when the numerator is less than denominator, then the numerator acts as the remainder and the quotient will become 0. Here the first remainder will be called as least significant digit and the last remainder will be called as most significant digit. So we'll have to write the binary equivalent of number from most significant digit to least significant digit. Now let us write 50 as 1 1 0 0 1 0. Now let us convert 25 into binary notation. So once again, divide the given decimal number by 2. 2 1s are 2, 2s are 4, remainder is 1. 2 6s are 12, remainder is 0. 2 3s are 6, again remainder is 0. 2 1s are 2, 1 is the remainder. 2 zeros are, and this quotient 1 will become the remainder. So first remainder is least significant digit and the last remainder is most significant digit. We'll have to write from bottom to top. So here you can find 2 4 6 bits, 2 4 5 bits. So what we can do here is we can add a leading 0 first, then we'll start writing from most significant digit to least significant digit. That is 1 1 0 0 1. Now let us add bit by bit from the right hand side. 0 plus 1 gives us 1. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 can be written as 2. Correct? So 2 can be written as 1 0. So here 1 is sum and 0 is sum and 1 will become the carry. Here I'll write 1 0 and 1 plus 1 is 2. Once again I'll write 1 0 because we don't have any columns on the left hand side, so that's the reason we have to write here 1 0. So how do you say 1 0 is 2? You can write the positional weight of this 0 is 2 to the power 0 plus the positional weight of this one is 2 to the power 1 into 1. So you can further simplify. 2 to the power 1 is 2. 2 ones are 2 plus 0 into anything is 0 is equal to 2 plus 0 is 2. Hence 1 0 gives us 2. Now let us take one more example of this kind. I want to add 15 and 15. So it must give me 30. Correct? Yes. So we are going to cross verify this result. Correct? So whether it is equal to 75 or not, and later on we are going to go for converting this one. Now let us check out the positional weight of this bit number 1 is 0 1 2 3 4 5 6. Here I'm going to write 1 into 2 to the power 6 plus the next bit is 0 into 2 to the power 5 plus next 0 2 to the power 4 plus next bit number 1 into 2 to the power 3 plus I'll write here 0 into 2 to the power 2 plus bit number 1 into 2 to the power 1. Next plus again we have got bit number 1 into 2 to the power 0. Now let us further simplify this. 2 to the power 6 is, it has to be multiplied 6 times. 2 is to be multiplied 6 times. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. Here I'll write 64 1s are 64. 0 into anything will become 0 plus 0 into anything will become 0 plus 2 to the power 3 is 2 2s are 4, 4 2s are 8. Here 8 1s are 8. I'm going to write 0 into anything will be 0 plus 2 to the power 1 is 2. 2 1s are 2. plus 2 to the power 0 is 1. Anything raised to 0 is 1. 1 into 1 is 1. Now let us further simplify. 64 plus 8 will become 72. 72 plus 2 is 74 plus 1 is 75. So whatever the result we got in binary is equal to 75. Now let us move on to second example. We are going to convert this 15 into binary number. Here I am going to write 15, divide this number by 2. So 2 sevens are 14, 1 is carry, 2 threes are 6, 1 is the remainder, 2 ones are 2, 1 is the remainder, 2 zeros are, this one will become the remainder. So first remainder is least significant digit and the last remainder is most significant digit. We'll have to write it from most significant digit to least significant digit, that is 4 times 1. So here I'm going to write 1, 1, 1, 1. Here also I have got 15. Once again I'm going to write 1, 1, 1, 1. Now I should get a binary number that is equivalent to 30. So let us add bit by bit from the right hand side. 1 plus 1 is 2. Just now we have studied. So 2 can be written as 1, 0. So carry will become 1 and 0 will become the sum. So 1 plus 1 plus 1, it will become 3. 3 can be written as 1, 1. Correct? So you can convert this one and check out. The positional weight of this bit number 1 is 1 into 2 to the power 0 plus the next bit is 1 into 2 to the power 1. Here I am going to simplify. 2 to the power 1 is 2. 2 ones are 2 plus 2 to the power 0 is 1. 1 into 1 is 1. So 2 plus 1 will become 3. So hence 1 plus 1 plus 1 will become 3. 3 can be written as 1, 1. So here carry is 1, sum is 1. Similarly 1 plus 1 plus 1 is 3. 3 can be written as 1, 1. Similarly 3 can be written as 1, 1. Because we don't have column on the left hand side, hence we have to write 1, 1 here as a sum. Now let us check out this binary number is equal to 30 or not. So let us count the positional weight from the right hand side. The positional weight of this bit 0 is 0, 1, 2, 3, 4. We'll write 1 into 2 to the power 4 plus the next bit is 1 into 2 to the power 3 plus next bit is 1 into 2 to the power 2 plus next bit is 1 into 2 to the power 1 plus next bit is 0 into 2 to the power 0. Now let us further simplify this. 2 to the power 4 means we have to multiply 2 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. Here 16 1s are 16 plus 2 to the power 3 means 2 2s are 4, 4 2s are 8, 8 1s are 8 plus 2 to the power 2 is 2 2s are 4, 4 into 1 is 4 plus 2 to the power 1 is 2, 2 1s are 2 plus 0 into anything will become 0. Now let us further simplify. 16 plus 8 will become 24. 24 plus 4 is 28. 28 plus 2 is 30. So here whatever the result we got, that is absolutely correct. Binary subtraction. So let us take an example. 33 minus 13. So that will give us 20. Here both of these two numbers are to be converted into its binary equivalent number. So we have to write first 33 and divide this number by 2 and we have to note down the remainder and quotient. We have to go on divide this given decimal number till the quotient becomes 0. Here I'll write 2 ones are 2, carry is 1, so it will become 13. 2 how much are 13 or less than that? 2 6 are 12. Here 1 is the remainder. 2 8s are 16, remainder is 0 because 16 is exactly divisible by 2, hence remainder will become 0. So again divided by 2, 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. Next 2 zeros are, and this quotient will become remainder. So as per basic mathematical rule that says when the numerator is less than denominator, then the numerator acts as a remainder and the quotient becomes 0. Yes, now let us write the first remainder as least significant digit and the last remainder as most significant digit. So we'll have to write the binary equivalent of this given decimal number from most significant digit to least significant digit. Here I have to write 1 0, 0, 0, 0, 1. 13 is to be converted into its binary equivalent. Divide this number by 2. 2 6 are 12. 1 is the remainder. 2 3s are 6. 0 is the remainder. 2 1s are 2. 1 is the remainder. 2 zeros are, and this quotient 1 will become the remainder. The first remainder is least significant digit and the last remainder is most significant digit. So we'll have to write it from bottom to top, that is most significant digit to least significant digit. You can notice that here we have got total 6 binary digits, but in the second number we have got only 4 binary digits. In order to match up with all the columns, we have to write 2 leading zeros first, then I have to write 1 1 0 1 1 1 0 1. Now let us start adding from the right hand side. So not adding, sorry, subtraction. 1 minus 1 will become 0. 0 minus 0 will become 0. Here I cannot subtract 1 from 0. I have to check out the borrow from the left hand side column. But in the left hand side column also we have got 0. Next we have to check out for 1. That is bit number 1 on the next left column. Here also we found 0 only. Again you can look for bit number 1. Here we found bit number 1. So what we are going to do is we are going to shift this 1 onto the next column and this bit will become 0 and this 0 will get cancelled. So where exactly we want this 1? We want this 1 here. So shift this bit over here. So it will become 1 and here it will be cancelled. So again shift this 1 over here because we wanted this borrow over here. 1 0 is what? 2. So here let us write 1 0 is 2. How I am going to prove it? So here I'll write 0 into 2 to the power 0 because the positional weight of this 0 is 0 and 1 is 1. I'll write plus 2 to the power 1 into bit number 1. Now let us further simplify. 2 to the power 1 is 2. 2 ones are 2 plus 0 into anything is 0 is equal to 2. So here 1 0 binary digit represent 2. Now you can see 1 0 is 2. 2 minus 1 is what? 1. Now you can see we have got 1 borrow. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. Now we have to check out whether this binary number is equal to 20 or not. So how to do that? We can verify by its positional weight. So here we'll take the positional weight of this 0 is 0, 1, 2, 3, 4. I'll write bit number 1 into 2 to the power 4 plus next bit is 0 into 2 to the power 3 plus next bit is 1 into 2 to the power 2. The next bit is 0 into 2 to the power 1 and the next bit is 0 into 2 to the power 0. If you want you can take this 0 as well. Here I'm going to write plus 2 to the power 5 into 0. Now 0 into anything will be 0 only. 0 plus 2 to the power 4 means 2 is to be multiplied 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 ones are 16 plus 0 into anything will become 0 plus 2 to the power 2 is 2 2s are 4, 4 ones are 4 plus 0 into 2 to the power 0 1 is 0 plus 0 into 2 to the power 0 is also 0. Here you can see 16 plus 4 will become 20. So whatever we got in binary digits, so that is equal to 20. Hence it is correct. Now let us take one more example of this kind. Here I am going to write for example 8 and then 1. So subtract 1 from 8. We should get 7. So convert this 8 and 1 into its binary equivalent. So how to do that? You can use the same procedure. Divide this given decimal number 8 by 2 and we have to note down remainder and quotient. So till quotient becomes 0 we have to go on dividing this given decimal number by 2. 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. Next 2 zeros are, this quotient will become remainder. The first remainder is least significant digit and the last remainder is most significant digit. So we'll have to write the binary equivalent of number from most significant digit to least significant digit. So we have to write 1 0 0 0. Next, how do you write 1? So even 1 can be divided by 2. Here you can say that as per basic mathematical rule says that when the numerator is less than denominator, then the numerator act as a remainder, quotient becomes 0. Here remainder is 1. So in order to match up all of these 4 bits, we have to write this 1 can be written as 0 0 0. So these 3 are called leading zeros, and then we have to write 1 over here. Now let us subtract bit by bit from the right hand side. I cannot subtract 1 from 0. So what I can do is I want to borrow 1 from the leftmost column. So here also we have got 0. Again check for bit number 1 from the next left column. Here also we found 0. Again you can check out for bit number 1 on the left hand side column. Here we found 1. So you can shift this 1 over here. Correct? So this 0 will get cancelled. This bit has shifted, it will become 0. So where exactly we want this 1? We want it here. So again shift this bit number 1 over here. This 0 will get cancelled. So again you can see that we have to shift this one on the right hand side. So 1 0 will become 2. Just now we have studied that 1 0 is 2. 1 0 is 2. 2 minus 1 is 1. So 1 minus 0 is 1. 1 minus 0 is 1. 0 minus 0 will become 0, and we have to check out that whether this 0 1 1 1 is equal to 7 or not. How to check? We'll use this method. The positional weight of this bit number 1 on the right hand side is 0 1 2 3. All right, 0 into 2 to the power 3 plus next bit number 1 into 2 to the power 2 plus next bit is 1 into 2 to the power 1 plus the last bit is 1 into 2 to the power 0. So 0 into anything will become 0 plus 2 to the power 2 is 2 2s are 4, 4 1s are 4 plus 2 to the power 1 is 2, 2 1s are 2 plus 2 to the power 0. Anything raised to 0 is 1, 1 into 1 is 1. Here you can see 4 plus 2 is 6, 6 plus 1 is 7. So whatever we got in binary notation, that is absolutely correct.